Hello. Welcome back. Hello, hello. How's everybody doing this beautiful Monday? Welcome back to Networks and Cybersecurity. Today we're going to do some looking at how to do all the stuff that we talked about in Java. Should I name this? Let's call this TCP UDP review. Alright. Let's see. A couple extra points to go over. First of all, shiny new light. So if my face is too illuminated now, let me know. In my opinion, it's a little too darn bright, but hey, some people said it was too dark before. Hopefully we've found a common middle. What else? Got your homework that this is partially based on due Friday, so don't forget about that. You've also got the lab as well, right? So don't forget about the lab too. And last week's homework, hopefully you already turned in the network statistics and everything homework. I'm not going to go over that one or the previous one unless there's a lot of demand, because both of those were really just kind of search the internet style homeworks. Not really a lot of fresh information there to cover. If you didn't find it before, just keep looking, because it's all out there. It's there's not much for you to do. It's mostly just copy and paste from wherever you find it. And you'll find that that's true of a lot of networked code. Someone else has probably done it better. You don't want to get too focused on reinventing the wheel. And we're going to try to cover threads really fast as well today. Alright, so let's make a simple, just console-based program for this. I'm going to leave the integrating it to the display to you guys, because that's its own level of fun, especially with all the threading good times. So let's go ahead and make a simple client. And this is going to be a little bit live for me. I don't have a lot prepared, so if I make a couple mistakes, my bad. Alright, I'm going to make a driver first. Let's call this driver UDP Client, because I'm going to make a UDP and then a TCP later. So I'm making a driver UDP Client, and I'm going to make my font a little bigger. That looks good. Alright. So we're just going to make another thing here called UDP Client. Not a huge fan of that name, but we'll go with it. Alright. And the only thing I'm going to do is take a port. So that's the only thing you need to set up a UDP client. So let's call it public UDP client. And we're going to need, remember, ports are just integers. Sockets are big fancy objects and everything. A port is just an integer. And so the only thing that we're going to do in the driver is instantiate the client. So this just gives you somewhere to click when you are first creating this thing. Make sure I'm on track here. You know what? Obviously you don't just need a port. Right? You need something else too. What else do you need besides a port if you want to send a message to somebody? What else do you need? Let's think about it for a second. You need something else besides a port in order to send a message to somebody. And then I'm going to use just a port of my choosing. I'm going to use 6112. Yeah, I need an IP address. How should we format the IP address? Should we use a string? Should we use an INET address? What should we use besides an IP address, or as our IP address? Well, the easiest way, I mean, you're probably thinking, is if I just took it as a string, would that work? Let's try it out. Let's call it destination. Creates a UDP client that sends messages to the given destination IP, the given port. IP in let's say traditional dot form, and port. Yeah, I think everybody knows how to use port, so we'll just leave that out. Alright, so let's try to just do it like that. So 127.0.0.1 for loopback, right? We want to just send messages back to ourselves. So let's see if that works. See if I can get loopback messages. Alright, in the client then, we're going to take keyboard input and just transmit it out to the server, and on the server end we're just going to take, let's say, a stream of keyboard input that's arriving on our end. So I'm going to make the server classes now too. So let's say driver Udp server. So you're going to have two main classes for your homework as well, probably, because there's going to be one to launch the driver, or sorry, one to launch the client, one to launch the server. So keep that in mind as you go. You're probably going to have to launch two separate windows. Now, later on, when we make applications that talk to each other, they're going to behave as both the client and the server, so that might change. You might launch the same thing on both ends. In this case, it's a one-way trip. We're just doing UDP, so there's going to be just one client window and one server window. But most applications are actually doing both, right? They're taking on the role of the client and the server. So let's see. All right. I'll do the same thing that we did before. We'll make a Udp Server Class. Okay, what do we need on the server's end? What does the server's end need? Does the server need an IP address to receive traffic? What do we need on the server's end? Obviously we need port, right? Do we need anything else? No, we don't, right? Not on the server's end. We don't need anything besides the port on the server's end. No, just need the port on the server's end. Okay, so let's do the server first, actually. It's probably easier to do the server first. So, Udp server. And we'll use 6112 as the inbound port. I use 6112 because it's the port used by BattleNet for hosting Warcraft 3 back in the day. And I had it unblocked for that, and so I just decided to use it anyway. It's not like I'm going to be both programming and playing Warcraft 3 at the same time, I thought. And yes, that's true. Okay. So you can always use a different port, remember. Anything other than the 0 through 1024 that are reserved, you can freely use. Okay, so on this end, on the receiving end, I'm going to need my Datagram Socket. This I never remember if it's uppercase or lowercase. So let's see if I got it right here. Datagram Socket. Is it... Yes, it is lowercase gram. Okay. So it's Datagram Socket with lowercase gram. Which makes sense, actually. I don't think gram was supposed to be a separate word there. So, alright, so Datagram Socket we're going to need in order to receive traffic on UDP. Let's do this not threaded first, and then if we have time, we'll go back and thread it later. So we're just going to block our main thread in order to read the traffic here. So anytime that you're reading network traffic, essentially all network code ends up getting boxed into try and catch statements, because there's so much that can go wrong in the conversion of the byte stream and everything. So generally speaking, it's all going to be inside of try and catches. You might as well just put everything in try and catch if you're lazy like this, but that's not good practice, right? So you should try to catch those errors individually. But just for this, I'm going to be a little lazy for the sake of time. So remember, it was quite easy, right? You just had to specify the inbound port that you're receiving traffic on. Oops, port. Okay, and so we're going to just receive traffic there. If you couldn't make it for some reason, let's say fail to create socket. All right, and then we're going to write our own method for receiving input. That way, if we have time, I will be able to convert this method into the one that's threaded. So this will be the threaded method, and that is not how you spell receive at all. That's a little closer. We'll roll with that. I before E, except after C. Receive. Good enough. All right, so in order to receive traffic, we'll call this at the end here, we need a buffer to contain our incoming bytes. And so typically we're going to use a byte array for that. And then I'm going to use something just to print to the console. So we'll just call it line for printing to the console. Now you want to receive data forever, right? You don't want to just receive one set of data and then quit. You can have a program that just waits for the next message, but did I remember that correctly? But obviously we want to receive data in a stream. We want to receive one piece of data after another. So we're going to have a like an infinite loop here, while true. And this is why you typically need to use threading, because the thread that waits for the input from the socket is going to be blocked forever. So you can't update the display or anything while you're stuck inside of this while true forever. So this portion needs to actually happen inside of a thread if you don't want the program to just be stuck inside of it. But we're actually going to have an exit condition. So let's say line dot equals whenever we receive the message exit, we're going to stop and shut down the server. So once we receive an exit, we'll shut down. Why did I make my byte array this big? Actually, it doesn't matter how big you make your byte array. Some people go like 1500. You'll see different examples in the book. I think typically people will make it this big because this is the largest that an IP datagram can be. Largest, therefore, that you can get on your UDP payload there. Actually, I think with headers it's a little smaller maybe, but either way, this definitely gives you enough room. It also makes sure that your program allocates enough memory to hold the largest possible size up front. But remember, they typically never show up this big, so you actually don't need to allocate this much memory. All right, let's try to receive something on this end. All right, so to receive something, we need to extract a datagram packet from the byte stream, and we'll make a datagram packet on the other end to transmit. So I'm going to just call it DP, and that's going to be a datagram packet. And when you extract a datagram packet, you need to give it a buffer, a byte array again, to save its information to. So we're going to save it to that buffer that we already have. And you also need to provide the length there. There you go. So what happens if you don't provide the length? Why doesn't it just figure it out? It's weird, right? Why doesn't it just figure it out? Why does it need you to provide the length? What happens if I provide the wrong length? So it says the number of bytes to read should be the length field. So you actually don't have to read all of the bytes that you get. If you wanted to, you could not fill the entire byte array. So it asks you for the length field in order to basically ask you what's the longest message that you want to read. So you could technically make this smaller as well, but I'm going to make this the whole buffer. So if you only wanted to read part of the buffer for one reason or another, you can do that as well. You can read the first so many bytes. right. And now just to receive this, we are going to very simply call socket. What do we call it up here? I'm very good at spelling, you can see. Receive. I before E except after C. Okay, let's change it. So receive input. All right, and we're going to receive on our datagram packet. So it's a little bit strange that you receive on the packet as an argument, right? It's basically saying receive on that socket and then use this datagram packet as your storage place, as your argument to store it. And at this point, what will have happened if we've successfully received a packet at this point is that we have stored the value, the payload of the packet, inside our byte array. So at this point, the byte array should contain the payload of the packet. So at this point, the byte array contains the payload of the, let's call it UDP datagram to be precise. Okay, so buffer, let's name it the byte array buffer, contains the payload of the UDP datagram, which means at this point we can just treat it the same way that we treated the byte array that we were reading from a file when we were doing the other homework. At this point you just have an array of bytes and you can do whatever you want with it. So let's go with, well, let's make a method for converting bytes to a string. Just call it bytes to string. We already remember that we can just do this with something like this. Line equals new string, and then we would call buffer, and then we would say something like the character encoding. We did this on the homework as well. We do something like that. That would work too. But let's just make our own. So I like to put my return there so it doesn't bother me while I'm typing. And we're going to need a byte array as input. So first, I'll do a null check just in case. And then I'm going to use string builder in order to assemble this. So this is not going to be easy to do if you want to do all the different kinds of encoding. So this approach that I'm doing here only works if you're using the default encoding. So for your homework, you'll probably just do it the built-in way so that you can change the encoding as you wish. Okay, but just so we have a little bit of practice with reading byte arrays, right? So you need to loop through byte arrays on occasion for other things. I don't think we've had to do that at all yet, so let's loop through a byte array here. Let's get you through bytes.length, plus. What is the length of the byte array at this point, by the way? Once we get to this line in the code there, what's the length of the buffer? Is it still 65,000 whatever 2 to the 16th, or is it smaller at this point? What do you think? Is the buffer still this long, or is it smaller now? And we're going to append the character, the bytes that we have there as if they are a character. So this only works in encoding mechanisms where one character is 1 byte, right? Otherwise you have to figure out how many bytes there are in the character, and that's why it's really hard to do this for other encodings. So we're just going to append the byte as if it was a character. You should actually add one of these guys there to make it more explicit. Otherwise it's kind of confusing. Yeah, we can get length, and we can see how big it is. So we'll do that later. Let's leave that as a to-do. What is the length of the buffer at this point? We'll try to check the datagram packet's length and see how long it is at this point. All right, so we've appended it, and then when we are done appending it, we can return it. So it would be S, and then I think it's just to string, to get the string out of string builder. Okay, yes. You can also do concatenation here. Generally, you would prefer to do string builder because it's presumably a little bit faster when you're concatenating a bunch. And remember, again, this only works if each character is exactly 1 byte big. So if you send anything that's not UTF-8, it's not going to work. I'm going to leave this one commented out, so you remember that that's the way you can do it. Let's go bytes to string, and then we're just going to pass in buffer, because at this point buffer contains the payload, and then I'll just print it to the console, and that'll be it for here. So let's say, received, unfortunately, such a common word in networking. Such a common word. And yet, so difficult to spell. All right, and that does it for the server. Now, unfortunately, again, you have your infinite loop here until you hit exit, so you wouldn't be able to use a display here unless you thread it, so something to think about for your homework. All right, on this end, on the client's end, we haven't done anything yet, so let's get started on the client. So the client needs to be able to send datagrams out into the ether. And we're going to get keyboard input to do that, so we're going to keyboard the old school way. Let's go with buffered reader as our old school keyboard input. So buffered reader. Did I get it? Nice, I got it. Okay. And we're going to set it up. Have anyone remember how to get keyboard input the old school way? Do you even remember how? It's probably been so long since you've been in Swingland, but I think in other classes you probably had to get keyboard input the old school way. So you need a buffered reader, an input stream, and then what do you give it as an argument again? Probably been a while, hasn't it? What does input stream reader need as an argument? Some kind of input stream here. Forgot my new. What do you put there again to get keyboard input? How long has it been? We'll put everything in a try catch again. You know, I'm going to not actually, and we'll see if it bothers me, just because I've been doing it already for all of them. So let's see what happens if I don't remember ever using this. Well, how did you guys get input from the keyboard in the classes where you didn't use a graphical user interface, if you didn't use a buffer reader? So if you didn't have GUI, how did you get input from the keyboard if you didn't use a buffer reader? I'm going to need to store the port here. This is the port of what? The destination or the outbound port here? Scanner, use scanner. You can also do scanner. Scanner's fine too. I use input stream reader. It's pretty much the same in concept, but system.in was what I was looking for there as the argument. So scanner or buffered reader, same thing. Might use maybe I'll use scanner here later. Should I use scanner here later? Yeah, it's too much work. I've already done this. I'm going to stick with it. So yeah, this is an alternative to scanner. Is this the port of the inbound or outbound connection? Well, this is the port. This is the listening port or inbound port on the server. So remember, this has to match. So I matched it already. I just hard-coded both of them to 6112. And your homework, you have to allow the client to enter a port on their end, but on the server, you can still hard-code it because the server is not going to change the port it's listening to, and that's because in order to change the port that you are listening on, you would have to start a new socket. So not a big deal, but something. Maybe I should have done that as a bonus, so you would have to close your old socket and start a new one with the new port in order to change. All right. Let's go ahead and make a couple other things while we're here. We'll need a Datagram Socket. So we've got our Datagram Socket there. And we'll need an INET address, I don't think. INET address. Let's see if I got it. Yes. All right. We'll need an INET address because we can't use this string destination forever. But how do we get an INET address from network address represented as a string. Can we do that? How do we get a network address from one that's represented as a string? So let's say I want to get the destination IP from our properly formatted string there. Is there anything in the inet address package that lets us do that? There's a get by address, which takes a byte array. We don't want that. There's get by address that takes a string host. That's probably not it. It also takes a byte array. Then there's something called get by name. And it says, okay, determines the IP address of a host given the host's name. The host can either be a machine name, such as java.sun.com, or a textual representation of its IP address. Okay, so you can actually use machine names here as well, which is one of the things that we extracted for the last homework, right? So if you're doing this on your own network, you could actually use your machine name too, as you've uncovered it. And that's convenient because even if the IP address of that machine changes, its name will not. And Java will figure it out on its own, I think. I haven't actually used the machine name in practice, but I believe it'll just figure it out on its own what the IP address is. But we're going to use get by name destination, and of course it's red. And why is it red? Because like everything else in networking, it needs a try-catch block. Seriously, everything needs a try-catch block because everything can fail. Okay, I haven't bound the port yet, so let's do that. There we go. That of course links it to the port up at the top here. And we are going to need to make the socket too. So let's go with socket. Let's new Datagram Socket. Do we need to specify anything here? What do we need to give it? Look at that, another try-catch with its own different exception. So best practices, you'll end up with like 10 exceptions, if you put everything in one block like this. Do we need to give it anything? Let's think about that, and we'll maybe come back to it later. See if we need to give it anything. All right, and here we're going to get input. We'll call that, again, one of those threaded things that we're normally going to add later. Okay, I'm going to copy my server's code, and we're going to recycle some of it, because it's going to be a little similar. Going to be a little bit similar. So, instead of a buffer, we have a payload. Payload has no size by default. I'll just call that null originally. Okay, and we're going to keep going until exit is typed as well, so we'll just close when exit is typed. The line will be what we're transmitting rather than what we're receiving. And I'm going to, this is going to be failed to send packet. I don't think any of this stuff will be useful, so I'll get rid of it. So we just have some of that block around it. Okay, so we're going to read the next line of keyboard input. It's going to be in.readLine. I think it's the same thing as in scanner, right? Scanner is maybe next line, or scanner.next if you're getting keyboard input that way instead. So very familiar it should be. We'll print out that we're transmitting it. All right. And then we're going to get our payload. I'll just do this the lazy way because we already did it the hard way previously, but you should remember how to get the bytes from a string, right? It's something like line.getBytes. That uses the default encoding. If you wanted to do, let's say, UTF-32, you would have to do something like that. That probably. This needs to be surrounded in a try-catch usually as well, depending on what encoding you're using, because it has a chance to fail, because that encoding is not available on the system. So we'll just leave it as the default maybe, and that should just send as UTF-8. Well, let's be specific. Let's say we're going to go UTF-8. All right, and now we need to build again a datagram packet. This time we're building one that's actually outgoing. Oh, I should have kept this line from the last one. So this one, we're actually building an outgoing datagram packet, and instead of a buffer, we're putting in the payload, and of course we want the whole payload, so we'll just put payload.length. Again, you could send just part of a byte array if you wanted to. I'm not sure why it supports that feature, but hey, why not? And now we also need a little bit more information. So this one's actually outgoing. So for the outgoing datagram packets, we need to provide them with their destination. That's just going to be the destination we've established up here, which is an INET address. And we're going to need a port, which is also the port that we established up here. Okay, so we've got our INET address and our port. Okay. And that gives us an outgoing datagram packet. And now we need to put it into the socket and send it on its merry way. And that's as simple as socket.send. And then you put it inside of the socket. And that's it. Goes off on its merry way. And hopefully it arrives at its destination there. Okay, so when you're finished with a socket, you should clean it up. And I didn't make this a bonus or anything. I don't think you have to make multiple sockets for your homework. But let's go ahead and make a cleanup method for it. We'll call it close socket. And I'll document this as well. When you hit enter, it sends data as UTF-8 to the server. Type exit to quit. Okay, and on the close socket end, closes all resources. So we'll say socket.close, and wouldn't you know it, that's all you need to do to close the socket. But we should also close the scanner that we were using, or the input stream reader, so we'll do that too. And that one, like many other things, needs to be inside try catch. So we'll close the socket, and we're also going to close the scanner. Alright, let's see if we did everything right here. I think there weren't any surprises here. So I'm going to start the server first. So I've got my server running here. Now it's a little bit annoying when you're doing it on one machine. I'm going to start the client and let's see why. So down here in the console, you can't see it probably because it's too small, but it says that I've got my driver UDP client running, right? So in order to see the different things I have running, you can either open two console windows, or you can use the drop down here. It's this little terminal. It's next to the new window. There's a drop down arrow, and you can choose between the currently running applications. Now Eclipse is a little bit clever, and once I type something on the client side, it's going to see that there's a system out on the server side, and I think it'll switch. So let's try to send something, hello world, and then I hit enter, and see it switched to the server, which is awesome. So good job, Eclipse, for figuring that out. So we sent we sent hello world, we got it on the other end. Let's see if I can pick those up in Wireshark. So if you installed the loopback adapter, I don't need an update. This adapter here for loopback traffic. Let me say IP.source, and then I'm going to type the loopback address as my source. Okay, and then we'll start a new trace with that. And let's send hello again. And there it is. It went out to myself. There's hello again. And let's say I want to see also the ones coming in on the receiving end. So I can do ip.dst is short for destination. And same thing, 001. And that's going to be, looks like you just get the inbound ones, actually. Looks like you just get the inbound ones. But that's okay. So if you had this on two machines, you could run Wireshark on both machines and see both the outbound and inbound ones. And notice in the payload, I see that hello again. Now, look at the source port, right? The source port is 64535. Okay, so when you created that socket, on the client end, on the sender end, you didn't specify a source port there. You only specified the receiver's port, so it automatically generated one for me, right? So this is that automatically generated port. And if the communication were two-way here, then we would probably use that one for our communications the other way. Now, the problem with UDP is that both ends need to have a port open in order for UDP communication to happen. So this is why sometimes, especially for your assignments, you'll probably specify a source port in some cases when both ends need to talk to each other. Someone said when they run theirs, it terminates instantly. Well, I'll post the source on the interwebs there soon. But you probably forgot, my guess is you forgot this not. That's probably the easiest error to make it terminate instantly with no errors. Actually, no, that would still run. I don't know then. I don't know what it would be. One of those things. Probably a missing read line or something. So I still, in order to get back to typing, I have to use a little drop down here and switch back to the client. Let's try to exit. So if I send exit, they should both close themselves out. Okay, I get exito again, which is a little bit weird because it just kind of wrote over my other message, but it did, let's see, terminate on the client side. It did not terminate on the server side, so let's see what I did wrong there. What did I do wrong here? So I got the message exito again. That's a little bit of a hint of what I did wrong. By the way, remember to stop infinitely running things. You got to hit this red square. Now, if you don't do that, if you just keep running it, you're going to have to hit a lot of red squares. So just make sure everything in your little drop down here is terminated. If you leave too many of these running at once, eventually you'll start to see the resources go by. So on the client side, somebody's saying I would terminate immediately without sending it to the server, right? So I would at this moment that exit is typed here, I would terminate immediately without sending it to the server. That could be it, but not actually probably it, right? Because the read line occurs down here. So it actually not enter the next generation of this while loop after doing all this stuff. And I do get exit O on the receiving end. So the problem is actually that if you use a buffer like this, a buffer of bytes, and you don't clean it up after every message that you get, you have the old message in there still. So I have the rest of hello and again from the previous message that I typed still inside of the buffer. So I need to purge the buffer basically every time I receive a new message. So how do I purge the buffer? What's the easiest way to clear out an array of bytes? What is the easiest way for me to clear out an array of bytes? Overwrite with empty quotes. Oh, I wish it was so easy, but it's an array of bytes, not a string, so I could go with does that work? It's not quite empty though, right? Because even empty is double quotes. Yeah, set the byte array to a new empty byte array would be the easiest way, I think, to do that. So just basically reinstantiate it. It's probably not like the most memory efficient way to do it, but it actually isn't that bad because this amount of memory has already been allocated for it. And then we were also going to figure out what the length of the buffer was at this point. So let me add it to my print line here. Let's go with, let's check buffer.length first and see how long buffer.length is. Okay, so again, I have to run them separately, so I'm going to start the server first, and then I start the client, and I see them both running here. Hello, Earth. Okay, so that registered as the maximum possible length. Interesting. All right, and now let's see if that exit bug worked. So exit. Received exit with length, etc. Now the client has terminated. The server is still running. So what did I do wrong there? Let's see. Line has to equal exit for it to terminate. Interesting. So why didn't it terminate there? Interesting. Did it not read exit exactly correctly? Here you run into some fun stuff. So it might have not necessarily read exit exactly correctly. It might have read like exit with a space or a slightly different exit. There are so many reasons why this can go wrong. I'm not even going to get into diagnosing it. So just be aware that all kinds of fun stuff can happen in transit there. All right, so that was buffer.length. Let me try DP. Let's see if there's a DP.length. Somebody proposed that before. There is a get length. Let's try that. So again, I got to run the, make sure everything's terminated. I hit that red square to get rid of the other ones. By the way, before we move on, let me try to run both servers at the same time. I'm going to try to run two servers at the same time. So I'm going to start a second one. It's the client, isn't it? Yeah, it's the client. Oops, close those out. Okay, so I'll try to run a server and then another server. What happens? Oops. What's all that, huh? So if you have two servers running at the same time, no bueno, so make sure that you close it. As you can see, the original is still fine and dandy, but somebody posted in chat that they got a address already in use cannot bind exception. So you probably left one of the other servers running, or you have 6112 being used for something else. Maybe you're currently playing Warcraft 3 while you're in class, which you should not be. All right. So let's run the client as well. And try this again. Hello world. Now it's length 12. Okay, so that's a more realistic estimate of the length. So if you need the actual length of the message, use the datagram packet utility method, not the buffer, because the buffer will just continue to be the whole space, right? And that kind of brings us to another question, is how does this work? If it's reading through all of the bytes and it uses the bytes.length, how does this work? Well, actually, all of the bytes that aren't filled in are null. So it's actually, when it's appending, it appends nothing. So it just appends like a blank nothing. So it doesn't actually append anything to the string. But this code sucks because it actually reads through the whole 65,535 long byte array, and that's totally unnecessary. So if we downgraded this to, say, 1500, type that on the wrong end. If we downgraded this to, say, 1500, and again, it doesn't exit. First of all, let's see if it still runs. Sure it does, and now we don't have this giant byte array. Yeah, and that might be also why it's not terminating when I hit exit, right? Because it's just not reading that string correctly. So let's try the way that you promptly did it and the other homework. Let's see if I just read it as UTF-8, if that solves all my woes. Let's try it out with a hello world. And then let's try an exit. And it still hasn't closed. So that wasn't it, but easier. And now we've shown that both of those approaches work. I'm going to go back to the original. So again, you can do whatever you want here in terms of length. This would be the longest you receive, so you'll see a few different examples if you look for this online. But I think most commonly you'll probably see just the max, because premature optimization is just another kind of evil. All right. So any questions so far? Obviously, it's going to be a bit of a chore to convert this. So let's try to make a threaded version real quick. Let's see if we can make this threaded. We'll just go with threaded on the server's end. So there's not going to be a lot of evidence that this is threaded because it doesn't do anything else in the background. But let's just try it. So the simplest way to get a thread going is to extend thread. You can also implement a runnable. You can implement runnable up here, or you can create an anonymous class of a runnable. We'll do that later. Anonymous class runnable is usually my preference for when we're making a threaded application. But let's say we're doing it this way. All right, so threaded applications just have this one method somewhere that they look for called run. It needs to be named run specifically. And so all we need to do to make this threaded is to put our receive input in the run instead, and then make sure that the thread is actually started. So when the thread is started, it will execute its run method, and that will be what runs on the thread there until it finishes. And obviously you'll go into a lot more detail on this when you actually formally cover threads in whatever class you're doing that in. But for purposes of networking here, I think that's pretty much all you need to know. Now, how do you start the thread? It's not thread.run. It's actually thread.start. So we're going to call server.start in the driver, and that should start that thread on up. And that's it, because we put it all in a method. It's that simple to convert it. Let's see, how can we prove that this is threaded? What can we do in the background that proves that this is threaded? Well, let's you know, I don't know. I'd have to do something else in the background to show that it can do multiple things at the same time. For now, let's settle on making sure that it works. This is something that, again, you're going to have to do in order to get your displays to run while the network traffic and everything is going. So everything still runs, which is lovely. Okay, and we received that exit, which failed here on the server end, so I remember I had to close it manually, but everything still runs there. Anyone remember how to do it with an anonymous class instead of using the extends thread? Anyone remember how to do it with an anonymous runnable? This is my preferred way, but if I'm being honest with you, I will probably fail to type this correctly. I'm going to give it a go since we only have a couple of minutes here. Let me try to embarrass myself here. I think it's a new thread, new runnable. I should really just look this up. Yes. Let's see. And then it would be the closing bracket here, and then dot start. Yes. Okay. Very clean, isn't it? This allows you to not have to extend thread, which can be useful for various reasons. It also allows you to generate multiple threads in the same program this way. You could also not make these anonymous. You could give them a name instead so you can reference them. But generally speaking, you're going to just have this reference to whatever method actually runs. And now you can make as many of these as you would like. Maybe you would make one for every different port or what have you. And this is directly in the constructor, so now you also don't have to remember to start it in the driver. I never like when you have to start things. You could actually start the thread in the constructor too, so that wasn't required or anything. But I never like it when you have to do multiple lines to get started with an object. So let's see if I did that correctly, and there we go, that's threaded too. All right, that's it for today. We'll probably do a little bit more with the threading, and we'll probably do a TCP thing as well on Wednesday. But you don't need TCP for your homework, and this is probably all the threading you need here already. I will post this to Canvas 2 for you. And I think that's it for today. Thanks for tuning in, guys. See you on Wednesday.